Hello guys, today we are going to talk about the derivative using a Newton backward interpolation methods. Okay, so there are many methods in interpolation, but right now, we are doing the derivatives of all these methods. Whenever we come across a situation that we are come in need of to find the derivative of that interpolation, so what we will do over there. Okay, so this is the Newton backward difference interpolation formula. Okay, you can see it is nebula. It is f naught phi nebula f naught plus phi plus 1 nebula square divided by 2 factorial and so on. You can see here it is a Newton backward difference interpolation formula. So now I will take the derivative of this formula with respect to this. Okay, with respect to phi 1 over h. So to draw this, that how we got this 1 over h and 1 over h and divided by dfe to take the with respect to phi the derivative of this with respect to phi. Okay, it is also a long process, but right now I'm not going to that. I'm just going to solve an example by using this formula and this method, and to take the derivative of this and then to solve an example of that derivative. Okay, so this is the formula. So I'm going to take the derivative of this with respect to this. So you can see, and so now to take the derivative of this above formula, I'm first signify, I'm just going to signify it so as to make either for myself to take the derivative. So I make it either phi square plus 1. You can see here phi cube plus 3 phi square plus 2 phi. I make it also is to draw it easily, to take the derivative it easily. So right now I'm going to take the derivative. So you can see here's a 1 over h derivative of phi. So I'm taking the derivative with respect to phi of all this formula. So you can see here with respect to take the derivative of this sorry, this is as I signified this one. So if not would be 0. As you can see, we are taking the derivative with respect to phi. So 1 over h if not will become 0. And you can see here we will consider this as a constant. So to take the derivative of phi with respect to phi, so it will become 1. And you can see from here it will become 2 phi plus 1 del square divided by 2 factorial. If not, it will become 3 phi square plus 6 phi plus 2 del cube 3 divided by 3 factorial. If not, and so on as up to infinity. Okay, so the first derivative is this. Okay, this is the first derivative. To remove 0 from here, this is the first derivative formula of Newton backward difference interpolation method. Now I'm going to take the second derivative to make the second derivative formula of Newton backward interpolation. So you can see from here, if I took the derivative as I took the derivative of this, so it gives 0, because you know that you are taking the derivative with respect to phi and there is no phi. So we consider this as a constant, so it is 0. From here you can see 2 phi will become 1 and 2 pictorial, so it will become cancel with each other. And you can see from here 3 3 duna chi 3 duna 6, 3 and 3 multiplied by 2, it will give 6 and plus 6, and phi will become 0. So we took the 6 as a common, so 6. And you can see it is 3 factorial, so 3 multiplied by 2, it gives also 6. So 6 multiplies 6. Okay, so we also got this formula f double dash. This is formula of double derivative Newton backward interpolation formula. Now I'm going to take the third derivative of this formula. So I will take the third derivative of this of second derivative, and then I got this formula from this. Simply derivation, you can also do it. Okay, so 1 over h cube, it will become 1 over h cube. The second derivative was 1 over h square, and the first derivative was 1 over h. You can see from here as 1 over h, 1 over h, 1 over h square. You can see, and the same here is 1 over h cube. As we was so the value of the power of h will become greater and greater and up to infinity. So this is the third derivative. Okay, and third derivative, it will, if del square of f not becomes 0. And you can see from here that this is the third derivative formula. Now this is the example what they are asking, they are asking for, they wants to interpolate if not 1.75 and if double not 1.75 and triple not 1. The example of this question will be like that. Okay, so they will ask for that type of thing, that they will ask to interpolate the derivative formula of Newton forward, Newton backward, as there's nothing to do this with a Newton forward. But I took this example from myself, that's why there's nothing. Okay, so for as we know that first we should to find the table, the difference table for this. So here is a difference table. It's given value, and you know that nebula if not, nebula square if not, nebula cube if not. To subtract this from this, 2.40 minus 2.02, we got this value. 2.76 minus 2.40, we got this value. To 3.10 minus 2.76, we got this value. And the same to subtract this from this one, to subtract this from this one, I got. And finally I reached this value. Okay, so there's nothing to subtract this from as anything. So this is the last value. So okay, it is the last value and it reached to nebula key 4, so I will extend my formula just to nebula key 4. Okay, but before that we need also the values of phi, because you have seen the phi mean there's a phi and the formula, so I should also need to find the values of phi. So how I will find the value of phi? From here you can see that as the formula x of phi x r plus phi h, as given in the question, they ask for to find the interpolation f double, as I showed you that they wants to interpolate, that means f dash, f double dash 1.75. So it as actually x of phi, x of phi we will consider as x of phi. So from here we got this value, and h we will take subtract the x naught from x1. So actually it is equally spaced data. So we will get the same difference by subtracting x2 minus x1 or x3 minus x2 or x1 minus, so it is 0.5. And to get the x naught values, as to get the values of phi between 0 and 1, it is a condition for phi. So that the phi value must be between 0 and 1. It must be greater than 0 and must be less than 1. So as you can see from here that the value of x of phi is equal to 1.75. 1.75. So 1.75 comes between which two intervals? You can see from here was 1.05 comes between these two interval 1.5 and 2.0. So first I will consider x naught 1.5, and second I will consider 2.0, or first I will first I will consider this, and second will this. It doesn't matter. Okay, so first I consider x naught is equal to 2. So you can see from here to find the value of phi, it will we will shift this to this side. So x phi minus x naught, and to divide h to both sides, divided by h. And we know the values of h 0.5. We know the values of x of p 1.75 from here. So it gives the value of phi minus 0.5, which is not correct, because they have given the condition that the value of phi must be between 0 and 1. It is not between 0 and 1, it is less than 0. So now I am checking on this value, mean I will consider x naught equal to 1.5. So from here we can see, as I consider x naught 1 for 0 1.5, so it gives 0.5, which is correct one. So now I am going to find the f dash 1.75 value, as I got the value of fear, and I got the 0.5 means x naught value also. It means that our interval will start, mean our first value will be start from 1.5. So you can see from here, as I have written also here there, which is correct value, because it comes between 0 and 1. No, f dash 1.05. So f dash, so to first find the formula, as we have already find the formula. So you can we will just put the values in this formula. Okay, we have already find this formula. Let me, I'm showing you that you can see from here f dash x of phi, this is the formula. So I will just write that formula and will just put all the values, all the values from the difference table. Okay, so this is the formula. So now you can see 1.0 0.5, it is h, and del f of naught we'll take start from here. You know that x naught is equal to 1.5, so we'll take start from here. So you can see delt f naught is this value, and we will just go like that to upside mean upward. So it means it is backward, so we will just go upward, and this is just in this case. Okay, so I put the value of del f naught. You can see from here 2 phi 0.5 plus 1 del square of f naught. What is the value of del square of f naught? You can see from here is this, and del cube is 0, and del cube 4 is nothing. So we will leave, we will just limit our formula just to that place, just to that position. You can see from here is I wrote 0 instead of del key 4. Okay, so finally I got I don't have, I haven't signify, I haven't compute these values, but you can compute. It will give just a sample answer. Okay, so it become 1, and to add these two minus 0.02 and 0.34, and to divide these two values on 0.5, it will give our answer. Now, as for the question, they've already asked for a double 1 over 7.5. So first to write if double x phi formula. So let me show you that if double dash derivative formula is this. You can see from here is the formula, and I put all the values 0.5 del square f of naught. We'll just put that values from tabulated tabulated difference table. Double square is the value. Okay, uh, del square of naught value is this, and del cube is 0. You can see from here. So, and it is already 0, there's nothing. So it is second, it is third, and third formula is this, and I put all the values. Okay, del cube f naught is 0. You can see from here. You can see del cube f naught, del cube sorry, here. So it gives us 0. I hope you have learned what I taught you. Okay, Allah Hafiz.